So I have to explain question 46, or what was OP standing for? I don't know. OP3. So the question is, a metal storage tank with volume V is constructed in the shape of a right circular cylinder surmounted in a semi-hemisphere. What dimensions will require the least amount of metal? So the first thing that needs to be noted with this question before you start is that V is treated as a constant. If you don't realize this, you cannot solve the question. So because I'm terrible at art, this is my little diagram. And from this, we can show that h is the height of the right-hand cylinder, while r is the radius, so before you get confused. And then I start with the volume of the tank, which would be the volume of the cylinder and the volume of the hemisphere, which is equal to pi r squared h at 2 over 3 pi r cubed. And as the volume is given and is seen as a constant, we can then figure out h from this. So h will then be, just from manipulation of the formula, h is v over pi r squared minus 2 over 3r. But because we don't want to be working with h, particularly as later we have to differentiate, we eventually will have to figure out h in terms of r, which we did via using the surface area. So, blah blah blah, you can see my working. Anita's not going to watch this. I'm so done. So the surface area of the tank is figured out from the surface area of the semi-hemisphere as well as the cylinder, but one must remember that you are only using the surface area for one circle and not two. So your surface area for the cylinder is altered slightly, and eventually this comes to 5 over 3 pi r squared plus 2v r to the negative 1, and we used 2vr to the negative 1 instead of h due to the previous manipulation we did, so that we aren't working with h, because v can be treated as a constant. So when we differentiate, which we do over here, basic differentiation rules, the first thing to note is that as 0 equals 10 over 3 pi r squared minus 2vr to the negative 2, that this means that pi r cubed is equal to 3v, and this will be required later. And eventually we get to the answer for r in terms of our volume. But the question wasn't asking for just r, we also needed the relationship between the radius and the height. So we already have an equation for the height, and then we sub in